Alright gang, here we go. This is for Chem 2, Unit 13. We're talking about how to balance half reactions in a basic solution. So the previous video we talked about how to balance half reactions in acidic solutions, so now we're going to do it in basic solutions. Pretty much the same thing, only a slight caveat, because and remember before when we were balancing them, we would add H pluses to balance out the hydrogens. The problem is that we don't have H pluses bouncing around in an acidic solution or in a basic solution. So instead of adding the H pluses, you're going to do everything exactly the same, but what you're going to do is get rid of the H pluses that you put in by adding hydroxides to both sides. In order to neutralize the H plus, and you're going to create water. This will probably create water on both sides, so the water is going to cancel out with each other. All right, it's not as hard as it sounds. So let's follow their work here. So this is cyanide with permanganate producing these things, and they say it's in basic solution. All right, so we're going to balance this guy, break it down into two half reactions. Step number one. So here's your two half reactions. All right, and so then down here, we're going to balance it as if it took place in acidic solutions. All right, so here's your Cn minus and your CnO. Cn and Cn were already balanced. Got to balance the oxygen that's on the right-hand side, so we add a water. Then we got to balance the hydrogens, so we got to add two H pluses. And then we're going to balance the charges, so that we get two electrons over here. And then for the permanganate, you go from here to here. So your manganetes are balanced, and no more manganetes do you need. All right, oxygens, you got 4 and 2, so you got to put 2 waters on this side, but that means you got 4 hydrogens, so you got to put 4 H plus on the left-hand side. Then you got to look for your charges. This right-hand side is 0, left-hand side is 4 plus minus 1, so plus 3, so we need 3 electrons over here. All right, so this would be two balanced half reactions in acidic conditions. This is where life gets more exciting. Now remember, we don't have extra H pluses to balance in a basic solution. So here's what they're going to do. They replace, or they look at how many hydrogens they have, and then they're going to add that many hydroxides to both sides of the equation. So you got your H plus from before right here. We're going to add, since there's 2 of them, we're going to add 2 hydroxides to both sides. So 2 hydroxides right here, 2 hydroxides right here. Same thing with this reaction. We had 4 H pluses, so we're going to add 4 hydroxides here and 4 hydroxides here. We're adding them to both sides of the reaction so it stays balanced. Kind of like in algebra, if you do one thing to one side, you got to do it to the other. All right, this is going to neutralize your H plus. We know that H plus plus OH minus just makes water. So this top one, H plus, 2 H plus and 2 hydroxides here make 2 waters. And then down here, our 4 H pluses and our 4 OH minuses make 4 waters. All right, then we can cancel out the waters here. Over here we had 2 waters on the right hand side and only 1, so that water will go away, and one of these will go away. We'll lose that, so we'll just have 1 water over there. All right, and that's what we turn into right here, right? That guy right there. All right, and then for this guy we have 4 waters on this side, 2 waters on this side, so these waters go away, and we've got 2 waters right there. And so that's what they end up right here. So notice how, it really boils down to the same thing. The electrons don't change. You're just shuffling your waters around until it matches. And then we can check our atoms, our overall charge, to make sure it all makes sense. And then we can take our 2 reactions, multiply them by their common in order to get the right number of electrons, so on and so forth. And you've got your balanced chemical equation. All right. So this is this guy right here. So they multiplied one of them by 2 and the other one by 3, or something like that. All right, let's try one. So it says complete and balance the following redox reaction in basic solution. All right, so we got to figure out which one gets oxidized, which one gets reduced. So the chromium, well, this guy's in here, so we know each of these. So this has got to be a -2. This is a +1. So overall, this is going to be a -1 overall, and there's 3 of them. So that means our chromium has to be a +3. Oxygen's always -2. Chlorine, chlorine would have to be a +1. Chlorine. It's different for you, huh? All right, oxygen's -2. -2 overall. There's 4 of them, so that's -8. And then it's got 2 minus overall, so that means our chromium here has to be +6. And then the chlorine is going to be elemental, so it becomes 0. All right, just make sure we have a redox going on. Our chromium goes from +3 to +6. That means it loses electrons. Oxidation is losing, so that means our chromium is reduced or is oxidized. So we got CrOH3 goes to CrO4 2 minus. All right, so he's oxidized, and then the chlorine, it goes from that to that, gaining electrons, so he's reduced. All right, so we get ClO minus. So we got one thing being oxidized, the chromium hydroxide, and the one thing being reduced, this hypochlorite thing. All right, and Cl2. All right, now we got to balance this one. This was probably going to be the hardest one we've had to balance so far. Yeah, so we balanced the non-oxygen hydrogens, so chromiums are balanced. Now we got to balance our oxygens. So oxygens here, we got 3 oxygens here, 4 oxygens here. So that means we need to add a water to the left-hand side here. Now we got to look at our hydrogen. So we got 2 here plus 3, so that means we got to have 5 H pluses. All right, now we got to balance our charges. So over here, we've got a 2 minus and 5 plus, so that's a plus 3 overall. So that means we got to have 3 electrons bouncing around right there. All right, so this guy's all balanced. We got to try the next one, Cl2. We got to put that there. All right, make our chlorines balanced. Now we got to balance our oxygens. So we do that by adding a water. So we'll add a water over here. Okay, but now we've got 2 hydrogens. We just, it's kind of like one of those things. It's like, well, if I just keep doing things, it'll eventually work itself out. So now I've had 2 hydrogens over here, 2 hydrogens over here. All right, now we got to look at our charges. We got 2, 2, 2 plus. I feel like I screwed something up. Oh, yeah. I need 2 of those. There we go, because there's 2 oxygens here, so I got to have 2 waters, which means I have 4. All right. I was like, oh, they both equal 0. I don't need electrons at all. Well, that doesn't make sense. That's not a redox reaction. So anyway, so you got 2 electrons on this side. Okay, now we're in basic solution, so that means we got to add hydroxides to both sides. All right, so if I need 5 hydroxides on this side, so I'm just going to go ahead and change this guy to water. I'm going to make 5 waters, and then over here I'm going to get 5 hydroxides, right? Because I added hydroxides to both sides. Over here, same thing. All right, this is going to become 4 H2Os. All right, but I'm going to have to add 4 hydroxides to this side. Okay. Now I got to make sure my waters cancel and balance. Okay, so those are my 2 half reactions, and then we're going to redraw them down here. All right, so my top one, I got a water and 5 waters, so this water goes away, and this turns into 4 waters. All right, and then here on this one, I've got 4 waters, so this becomes 2 waters, and this one goes away. All right, then just to look one step further ahead, we got to look at our electrons. Our electrons, this is 3. Right, and this is 2, so we got to multiply them to a common. So we're going to multiply the top one by 2. We're going to multiply the bottom one by 3. All right, now if it's too confusing to do it all in one step, you can easily break it down. Whatever you need to do. All right, 10 hydroxides, OH minus plus, and the water got canceled out, so he's not there. So it'd be 2CrOH3. All right, and then 2CrO4 minus 2 minus plus 8 H2O plus 6 electrons. Okay, now this next guy here, he becomes 6 electrons plus 6 H2O plus 6 ClO minus gives 3 Cl2 plus 12 OH minus. All right, so that's that. Now we're going to add those 2 suckers together. So let's look for common things. So we got 10 hydroxides here, 12 hydroxides here. So those 10 are going to get canceled out, and we're just going to have 2 hydroxides there. Waters, 6 here, 8 here. So we're going to have 2 waters over here. And then obviously the electrons get canceled because that's the whole point. All right, so overall, this is what we'll have. We'll have our overall balanced chemical equation will be 2CrOH3 plus 6ClO minus goes to 2CrO4 2 minus plus 2H2O plus 3Cl2 plus 2OH minus. Just like that. Isn't that fun? So fun. These take a little bit of practice, but really, like, the nice thing about them is that there's not really any tricks, right? There's no loopholes, there's no catches. You just follow them down the list, right? Just one step right after the other. If there's oxygens, put the waters. If there's hydrogens, put the hydrogens, or the H pluses. If it's basic, turn the H pluses into water and add hydroxides to the other side. Okay, and you just kind of keep going like that. Okay, it's not too bad. You just got to do your practice problems. Soon in the next video, we'll talk about, well, why are these important? How can we use these to do something useful? And we'll start talking about voltaic cells. It's pretty interesting stuff. Anyway, so do your practice problems. Let me know if you have any questions, and I'll see you on the flip side.